Alrighty, so we had a few days coming back from break to relax and get our brain slowly into the mindset of math. And today's going to be our first day of actually getting into it. Okay, so we left off last semester learning about quadrilaterals and congruent triangles and congruent figures as well. And what we're going to be moving on to now is similarity. Okay, Unit 3 is all about similarity, and we're going to start by looking at these scale drawings. Okay, but before we start, let's go ahead and look at our bell work for the day. Okay, so here is our bell work. Okay, so given the triangle congruence type and the congruent statement for both triangles, right? So we have triangle 1, triangle 2. So does anybody have an answer for triangle 1?
Yes.
So side, angle, side. So where does the second side come from?
G and I are congruent to G.
Right here, G and I. This middle one is a reflexive property, so we have side, angle, side, angle, side. Okay, and what would the triangle congruence be? State my fault. Triangle statement, congruent statement.
Triangle FGI is congruent to the triangle HGI.
Perfect. Did anybody have something similar or have a different one?
I didn't even write it down.
GHI and what was the other one? GFI. Both of those are also work.
I don't
FIG
think GHI could work because doesn't the angle have to be in the middle?
Yeah, she did.
Isn't
Yeah.
FIG and HIG?
You said FGI for your first one, right?
Oh, I thought you said GHI.
Yeah, she did. She said GHI and then GFI.
The one that's in the middle, you're saying GHI, so that means this is the angle. But G is the angle.
She's naming the congruent statement.
Oh,
Yes, not the
okay.
angle, not the angle.
Okay.
Okay.
Oh, bro.
So triangle GHI, right, is congruent to triangle GFI. That's what she wrote down.
Like FIG and whatever this other one.
Yep, so either one of those work. FIG and HIG is also a good option for that as well. Okay, so for number 2, which one is this one? What congruency type?
SSH.
SSS. Anybody have anything different than SSS? Awesome. Awesome. So what do we know about line NP? Has to be what? Congruent to itself. So we have 1, 2, 3 sides that are congruent to themselves or to each other. So that means we have side congruency. And we can say something like triangle NOP is congruent to triangle NQP or something along that line. So N goes with N, P goes with P, and O and Q go together. So those just need to be in the same place. Okay, so if you have that, go ahead and put that into a safe place. If you would like to put that in the tray, go ahead and put it into the tray. We will be using this sheet for the rest of the week. I am going to figure out a way to actually physically write on this for the first one today. I think it's okay to just have it on the board since it's a bit of review.
How many points is this, please?
The bell work?
Yeah.
The whole bell work, each of these is going to be worth 10 points.
So 2 a day.
2 a day, yep.
That's like a little bit of extra credit.
Essentially, it's a good cushioning for you. If you, as long as you do the work, you get good cushioning.
You know, failure.
Alrighty, so let's go ahead and switch back to our notes. Okay, so let me ask you something real quick. So before, I used to call rulers, right, straight edges, because we would not do what with our rulers
Measure.
technically. We wouldn't measure. But if you looked at my materials, I have finally called it a ruler. So what that means is we're actually going to be using our ruler to measure distances. Okay, so let's go ahead and look at our warm-up for scale drawings lesson 3.1. Okay, so we have 3 hippos. We have the original hippo, hippo A, and hippo B. Says Diego took a picture of a hippo and then edited it. Which is the distorted image? How can you tell? Pause. Give a second. Go ahead and look at that. Okay, I'm going to read the next one. Is there anything about the picture you can measure to test whether there's been a distortion? Okay, so let's look at that first question. Which one is the distorted image? Okay, so do me a favor. You guys, does anybody know sign language? Okay, so A looks like this, a fist with your thumb on the side, and B looks like this. Okay, so A and B. So I want you guys to hold up which hippo is the distorted image.
B again?
A is this one, B is this. A like an apple, B is like this. Okay, so give me an A or B for which one you think is the distorted.
Pretty sure that was all that.
Okay. Okay. Seen a couple B's. None of them either?
A.
A. Okay. That's A.
Okay, see.
Okay, A. Okay. So I saw that Brinley put up A and B.
Oh.
A lot of people said A, lots of people B. Okay, what is your explanation, Brinley?
Distortion is just a difference from the original.
Right, so distorted is just different from the original, right? Different from original. Okay, now which one of these is not like the original though?
Both of them.
Not, which one is not similar?
A. I guess.
Okay, so same thing, give me an A or a B for which one is not similar. Okay, go ahead and raise your hand up. A or a B, which one is not similar? Okay, this one I'm seeing a lots of A's. So how can you say, why can you say that A is not entirely similar?
Because it's more wide than.
Just the width.
The width, right? The width is different. Okay, so good. So what is a way, hey boys, what is a way that we could measure this to test whether there's been a distortion?
Measure
Okay, what, yeah, but what are we gonna measure?
the height.
The height, the size? Okay, so let's measure the height of all of them, yeah?
The width.
Okay, so the height,
From the ears.
I'm gonna measure from the ear to the middle toe. That's about 2 inches. So the height is about 2 inches for this first one. Same thing over here from the ear to the middle toe. This height is about 1 inch. And if we go over here from the ear to the toe again, here, sorry about that. I can zoom in, sorry about that. From the ear to the toe again is another inch. So 1 inch. So we have a 2 inch, 1 inch, and a 1 inch. So far, they look like they might all be pretty similar because we have a 2, 1, and a 1.
It looks like B is just half of everything on the first one.
Okay, so what's another way? So we measured the height. That didn't really help us though.
Side to
We
side.
can measure the width.
And then do height times
Okay, so I'm
width.
gonna do the left side of the belly, touching the teeth. To the right side, this is about 1.5 inches. Oop, that's not a good line, my
Wasn't
fault.
it length times width equals what? Height? No. Length plus
max.
length times height.
Is the area.
The area, yeah.
So this is 1.5 inches. Okay, let's measure the wide hippo. It is also 1.5.
So.
And then let's look at the smaller hippo, which is actually about 3/4 of an inch. Ooh. Okay, so we have 2, 1.5, 1.5, and 3/4. Okay, so this way we can really tell what has been really distorted. Which one has the most obscure ratios of lengths? Right, this is 2 to 1.5, this is 1 to 1.5, and this is 1 to 3.4.
Which one's the most different?
Yeah, which one is the most outlierish?
The last one.
The last one?
I would say the middle one.
Right.
because it didn't
So we're
go
saying-
factor.
There's only one change with A, but there's 2 changes with B.
I like that.
I feel like he's more of like a
Proportional?
It's a scale figure.
Nice. It's more proportional, right? It's more scaled, right? So, another way we can measure our things, okay? Do me a favor, draw a straight line from all the toes of the piglets, or the hippos, my fault. So draw a straight line. Okay, and what we're gonna do, oh Nathan, what happened to your paper?
Oh, bro, what did you
Why'd
do?
you rip it?
Oh, because I wanted to.
Okay. Well, it's still usable, so please just be careful so you don't rip it all off, okay? Okay, so what I'm going to do is I want to see if there's any angles that I can make. So what I'm going to do is I'm going to go from the leftmost toe to the end of the tail. So leftmost toe to the end of the tail. I'm going to make that line. Okay, and an angle is made right here. Okay?
And then I'm doing it again.
And we're going to do it again for all of them. So leftmost toe to the end of the tail. And then leftmost toe and end of the tail.
So we're making hippopotamuses geometry of triangles and figures.
Yeah, we are. Okay, so what I need to know now is, will these angles help me figure out which one is the most distorted? Yes, sir.
I just had it.
Straight edge there in the cabinet or the drawer underneath the little paper cutter.
Right there, right here.
Right there, yep, yes, sir. Thank you. All right, so what I'm going to do is, I don't want to use a protractor to measure this angle, so I'm going to use a piece of trace paper. So my angle on this trace paper goes here to here. Okay, and if I move it to my figure A, does those angles match?
Yeah.
They do not, right? So here's my darker one. So my darker one goes right here, the dotted line, but my original A was the solid line. Do you think it would match with angle B more, or hippopotamus B more?
Probably.
So let's go ahead and look. Does that angle match?
Yeah.
Yes, the angle for B does indeed match. Okay, so with that information, which one of these is the most scaled drawing? Is it A or B? B. Okay, B is the scaled drawing.
We're trying to find the most distorted one, so it's A.
Okay. It looks more proportional. Do you guys know what that means when I say proportional? It looks like from the original, the
It looks
smaller
closer.
one has the same proportion. Same height, same width, but just in a smaller version. It looks more proportional. Okay, and we've done a lot of proportional solving proportions, right? So the name has to match with that. Okay, so that means that our A is the most distorted image. It is not closest to the original. Alrighty, so we're gonna use this information and this idea of scale drawing and being proportional to go ahead and look at more and introduce us to dilations. Okay, so go ahead and turn your page to page 310. Okay, so right here, go ahead and underline or highlight the word dilation, and go ahead and underline the word scale factor. Okay, so it says here, a dilation with center O and a positive scale factor R takes a point P along the ray OP to another point whose distance is R times further away from O than P is. Okay, that might be a little bit confusing right now, but we're going to use question 1 and question 2 to help understand that. Okay, question 1 and question 2 to help understand that. Okay, the second part, if R is less than 1, then the new point is going to be closer to O, not further away. Okay, so let's look at this again. So we have a center. So dilations are always going to be centered around a point. Okay, it's going to be starting from that point. So please underline the word centered, center O for me, okay? Okay, and remember it says here it takes a point P along the ray OP to another point that R distance away. Okay, so let's do a bit of an example because these words are a bit confusing, right?
Very.
Okay, so it says here, we want to dilate the point H using C as a center. So C is my center. So I'm gonna, we can label that if we want to, center of dilation. And we have a scale factor of 3.
What does that even mean?
Scale factor of 3?
Yeah.
Okay, so this
its size.
perfect. The scale factor is how much we're going to be multiplying its size.
120.
So from 40, what's 40 times 3? 120. Let me measure this and make sure it is 40 millimeters. It is indeed 40 millimeters. So we need to go to what measurements? If we want a scale factor of 3, we want to multiply by 3. So it is 100 and what? What are you talking? What? We're in millimeters. We're in millimeters.
12
We're starting with 40 millimeters.
Oh.
So if we're starting with 40 centimeters, or millimeters, right? Because each centimeter is 10 millimeters. So here's 10, 20, 30, 40. So you want to go to 12 centimeters or 120 millimeters. Okay, I was just trying to get you to millimeters because that's the unit that we are in. So my original is going to be the C to H.
Oh, this is third grader math. What are we doing?
We're introducing dilation,
I
sir.
don't even think this is in English anymore.
So we can call this now H prime. Remember, dilation is a transformation. So anytime we do a dilation, we have to have a prime there to show that we moved our figure. Okay, so Chase, Nathan, can you guys go ahead and follow along with me what I did there, please? And thank you. You need the full straight line. Full straight line with your straight edge. Nathan, can you get that for me, sir?
I just marked it over there. And I actually got a straight line.
Nathan, I'm asking you to follow along, please. Thank you, sir.
I just marked it. I didn't.
Appreciate that.
I didn't know I was supposed to draw a line. I just marked it.
Okay, that's perfectly fine. Okay, so our scale factor, our R, was equal to 3 here. Okay, and our original was 40 millimeters. So we wanted to do R times 40 millimeters, and we got 120 millimeters. Okay, because we did R, which is 3 times R, 40 millimeters. Okay, so right here, question number, well, anybody have any questions on number 1?
Wording was horrible on the paper.
The starting page, I agree. The example is a lot better than the wording, huh? I agree. Okay, question number 2, it says dilate K using O as the center. So I'm going to put my center as O. So is my point O going to move at all?
No.
No. What's going to move?
Okay.
The K. Okay, and it says a scale factor, so my R is equal to what? 3/4. So if K is 40 millimeters from 0, so here is, right here, bink, 40 millimeters.
It's like 3.5.
Well, you would go to 10.
Then we're
well,
just
it's
adding 30
it's 10
millimeters.
intervals, so you would keep only 10 of it. Because you're getting rid of 3, right? That's just how I'm doing it in my brain.
Kind of the other way. We want 3/4 of it. We want to get rid of 1/4 of it. So you were thinking about it backwards. What you said is get rid of 3/4 of it and keep 1/4.
Yeah.
We want it the other way.
Yeah.
Okay.
Wait, I thought in fractions they get smaller.
It is gonna get smaller,
That's 30.
So
but it's gonna be 3/4
we're
as
gonna keep
big.
30 instead of 40 of it.
I think, yeah.
We're getting rid of
20, you mean we're getting rid of? Yes, exactly. Yes,
Yeah.
we're gonna keep. Yes, perfect. Okay, so since K to O is 40 millimeters, so K to O is equal to 40 millimeters, right? It's not physically, okay, but they tell us it is, so this one's not drawn to scale. Okay, if it's not drawn to scale, we try our best to do that.
I don't know why I thought it was
Okay, so 40, so 40 meters or millimeters times 3/4 will be equal to 30 millimeters, which is where our K prime is going to be away. Sorry, our K prime is going to be 30 millimeters away from center O. Well, if I'm looking at my scale drawing, I can't. It's not 40 millimeters, right? So how can I split up my line to evenly split it up into fourths?
You want to get a quarter.
Right, we can split it in
Divide by
half.
4.
We can split it in half and then split the halves into halves. So I have 3.5 here. 3.5 divided by 2 is 2.75. Or wait, 1.75. You're right. So about right here is my halfway point.
Is it the tick mark before the 2?
Yes, the tick mark before the 2. A little bit before the 2, yes, around here. Okay, half of 1.75 is 0.5 plus 0.325. So 0.8 something. So it's going to be around right here. And then around right here. Okay, so 3/4 of the distance from O would be right here. So this needs to be our K prime. And we can label that the distance here is 30 millimeters. Why is it not focused?
What is this? What is it? Isn't it like 8.235 or 3.25?
Yeah. It's close to that.
0.8325.
Yes, it's exactly that actually. You are right. We're pretty sure.
I'm not running all that.
As long as you understand what we did, makes sense, okay? So right here though, you made your K on the wrong side.
No.
This would be if we had a scale factor of negative 3.4. So it needs to. So when we do scale factors, it needs to be on the exact same side as it was before. Okay. Nathan had his on the right side over here. Okay, he had his K prime on the right side. I'm doing this in pencil. This is incorrect because the original K was on the left side of the center. So if we want to keep it on the left side, our scale factor is going to be positive. If we want to move it on the opposite side, our scale factor is going to be negative. Okay, so can you fix that for me, sir? Please and thank you. Should be on the same side.
So you basically just divide 40 by 34, so that's your first tick mark, and that's where K is just going to
Not divided by 3/4, multiplied by 3/4.
sorry.
Yes, sir. Yes, sir. So anytime you want the distance with given a scale factor, you multiply your distance given by that scale
So
factor.
do I really have to do all that, or can I just do that?
Multiplying by the scale factor?
Yeah.
Yeah, that's all you have to do. I was just showing you guys how it looks like with distances, physical distances,
Okay.
instead of just numbers.
Okay, I just wanted to make sure that that's not like what happens every time, but
No,
what
no,
I'm
no.
seeing it does. So.
No, you don't need to do it. Unless it tells me, unless you asked to draw it, then that's when you'll be asked to draw it. All right, question. All right, any questions on 1 or 2 about looking at that dilation and the scale factor? Okay, so cool piece of notes that I'm going to add right here. If you guys, I will ask that you do put this on your thing. We grow or get bigger, right? Grow when our R is greater than 1. Right? We shrink or get small when our R is greater than 0 but less than 1. So between 0 and 1, so any decimal number between 0 and 1 makes our figure shrink if it's our scale factor. What do you guys think will happen if R is equal to 1?
It wouldn't move.
It'd be the exact
Because you're multiplying by
same.
one, so it wouldn't.
Awesome. Yes, yes. So this is our little shortcuts if you need it. So if R is greater than 1, we grow. If R is less than 1 but greater than 0, it shrinks. But if R is equal to 1, it stays the same.
I'm gonna leave it open for a second.
Okay, and then the last thing we really talked about was that if R was less than 0, right, it would flip sides from the center.
And if it's negative, is it always going to grow?
Same idea with this one. If it's between 0 and negative 1, it will shrink, but on the other side.
Okay.
If it's bigger than negative 1, or smaller, my fault. If it's smaller than negative 1, it will increase, but on the opposite side.
Oh, okay.
Okay. So no other questions about that? Awesome. Let's go ahead and use what we just learned to dilate this snowman. Do you guys want to do the whole snowman, or should we just do the bodies? Let's just do the bodies so we can cut some time. Give me a second. I just want to see what else we have after this. Scale drawing. Scale drawing. Okay. All right, so it says here, dilate the figure using center P and scale factor of 1/2. So our R is equal to 1/2. Are we growing or are we shrinking?
Shrinking.
We are going to be shrinking. Okay, we're going to be making this smaller. Okay, so how do we go about this? How do we make it smaller? Okay, like that. Okay, so do I need to measure the distance between P and B?
No, wait, you don't have to go to the end of the line? Or is it just to B?
Okay, we need to reference what we know. So we can say that we know from P to B is 11.5 centimeters,
I did
or should we do inches?
inches. I did inches because it's 4.5.
Yeah, so this is 4.5 inches. So I'm going to write right here, PB is equal to 4.5 inches. Okay, what about PD? Is 5 1/4. So PD is 5.25 inches. Okay, so if we know this distances, how will it help us use our scale factor 1/2? What do we do with our distances we just found in our scale factor? We multiply it by we multiply our distances by our scale factor. So that means our PB prime is going to be somewhere in the middle. So what is half or 1/2 times 4.5? 2.25. So I'm going to write right here 4.5 times 1/2 is equal to 2.25. So I'm going to measure from point P 2.25 inches. So here's 2, here's that 0.25. And what am I going to label this point?
Anything.
It's going to be B prime, right? This is a dilation, so we have to show we have done a transformation. Okay.
2.5 is what?
2.25. 2.25. All right, so if I go here, 2.25.
Okay.
Might be a little hard with my clear ruler to show. I can show you with this one. Right here, 2.25.
Yeah.
All right, so now our D is 5.25. So what is 5.25 times 1/2?
It can't be 2.7.
It would be 2.6.
It's not
2.6. Here, I have a calculator on my phone. We'll use that. These decimal divisions are getting kind of out of hand.
Yeah, it's like what is it?
You're right. This is multiplication. So it would indeed be 2.625.
Yeah.
Okay, so 2.625 is close to 2.5. I'm going to go a little bit longer than 2.5. 2.6, 2.5, 26.25. I'm going to just put it right about there. And I'm going to label that D prime. Okay, so we have these 2 points, and we use this straight line that they gave us to find them.
So don't we have to literally move everything over in between those that triangle?
One more time, sorry.
How far is D prime?
D prime is 2.625 inches.
Wouldn't you have to literally move the whole snowman into that little area?
We would have to move all of this in here, right? But how do we know where C is going to be? How do we know where A is going to be?
Because C is going to be in the middle, 1/4 of the way down from D and B, right?
Not 1/4.
No.
1/2 of the way.
Yeah.
Right.
We can make the snowman's head smaller.
That's
But
exactly.
we have to
we
make
are
the
gonna be
whole
doing.
snowman smaller. But yeah.
But where is the center of this top
A,
circle?
C.
C. So we would need the C over here. How can we move our C over here? How did we move our B over here?
By measuring the radius.
Nice. You're super close. We need the center before we can measure the radius. Okay. Okay, I like where your heads are going, okay? But what we need to do is we need reference lines just like we did for D and P. So going from point P, I am going to draw dotted lines going through our center of our circles, A, and the center of our circle, C. Because this is now the line that I'm going to use our scale factor and cut the distance from our point P in half using our scale factor. So I'm going to measure my point C. So our point C is 5 inches. So what is half of 5 inches? 2.5. So PC is equal to 5 inches. So 5 times 1/2 is 2.5 inches. So we're going to measure 2.5, and it will be right here for my C prime. Cam, you following along, sir?
Yeah.
Thank you. Okay, next we have our measurement of A. P to A is a little bit more than 4.5. So that's going to be a little bit more than, so P to A is equal to 4.5 through like 5.2, 5.3. Okay, dividing that by 1/2 or timesing by 1/2 will be 4.52 times 1/2. So this will equal 2.26. So close to 2.25. So 2.25, a little bit more. Right here
Too much work.
is my A prime. Okay, so over here, what is my radius of circle A? A to what? We have 3 options here for our radius. So from the center to the outside, we have A to for radius. A to what? A to B is a radius. A to what? A to E and A to H. These are all radii that we can use. Okay, so what we can do now is, I forgot to tell you guys to get compasses. I forgot we were doing the snowman part. So with your best estimate, okay, I know I need to make a circle with the radius of A to B. So my A prime B prime is going to be my new circle radius. And I'm going to make that right here. Okay, so go ahead. If you want to get a compass, go ahead and grab one. If you want to just go ahead and try to freehand it, I will accept that as well for this one. Okay. So there's my body. Okay. So we have successfully dilated the body of the snowman by a scale factor of 1/2 using P as the center. Okay, so let's go ahead and answer our question at the bottom. What do you notice? What do you wonder? Okay, so I'm going to give you guys about 2 minutes. Tell me what you notice about these 2 figures and figure out at least one thing you wonder about them. Okay, can you wonder something about their area, about their circumference? Can you wonder if everything went down 1/2? Did the radius go down by 1/2? That's a good question to ask. I'm wondering if that is true or not true. Maybe it is, maybe it isn't. Who knows? Okay, so go ahead. Look at what you notice. Write something down for that. And then go ahead and write one wonder. Okay?
right?
Alrighty. So a lot of people are finishing up. I still see a couple writing, but we're gonna go ahead and start sharing. So can someone share a notice that they found? So I'm gonna put a notice and I'm gonna put wonder over here. Okay, so Chase, what do you
Yeah,
notice?
that's why it's pretty simple once you get like the order of what to do.
Right.
But it's really
Okay.
difficult if like learning what order and like how to do it.
Okay. So like the process is simple
Like-
once you know what to do.
Yeah, like once
Okay.
you know to measure that, and then you have to, one half of it, and then doing the prime. I think.
But there's a lot of steps though, huh?
Yeah.
So simple process, lots of steps.
Yeah,
Okay. Anybody else have a notice that they would like to share?
have a really good wonder.
Okay. Now, I'm asking more specifically of the figures, but I like that notice. It is a pretty simple process, but there's a lot of steps that make it pretty hard to remember what to do.
For my
Really?
notice, I put that I already noticed that the circles overlap each other.
Okay, so the circles still overlap each other. Okay, so the circles still overlap. Is there two P's in overlap? I don't think so. Okay. All right, any other notices?
Frosty doesn't have his hat.
There's no hat.
Yep, that's.
There is
tragic.
no hat, which is very tragic. We can make one though, yeah?
Or arm.
We had to, it'd be more stuff we would have to scale though, down to the smaller one if we had that hat. Alrighty. Awesome. What do you guys wonder, Chase?
Okay, so I wonder if D to C is one half of A to B.
Okay.
Or whatever the scale would be, the scale factor would be.
Mm-hmm.
Like, I wonder if that's like a thing.
So from D to C to D prime C prime?
Yeah, well, yeah, and then from those are like one half of A to B. I didn't do like math. I could probably figure that out.
Wait, can you repeat that one more
So
time?
like if
Mhm.
these two
Mm-hmm.
is one half of these two, so it would be like if D was
Okay.
like this, and I wonder if C like
Is
D to C one
Is-
half of A to B.
one half of AB equal to DC. Is that what you're saying?
Yeah, or like
Okay.
if that applies to all scale factor, whatever the scale factor is, if like you can find that out. Or something.
Okay, okay. We would have to probably measure, but I don't think the scale factor would probably be able to help us. But that is a good wonder to have. Anybody else have a wonder? Hey, Nathan, can you not bend my ruler like that? You can snap it in half and break it. Please don't
He
do that, sir.
broke so many rulers last year.
Okay.
No, not.
Anybody have any other wonders? Okay, the one thing I really wonder about is, does the area also half?
I mean, yeah. I guess.
Okay, so since everything was scale factor by one half, would the area half as well? That is my question. I'm not too sure, but I want to know if that might
Would
be
you ever
true.
have to use pi in this?
If you were to solve for like the actual area, yes, we would. Pi r squared.
Dang.
Isn't it just 3.14 times radius squared?
Mm-hmm.
That's still a lot of extra work.
But alrighty, so this is your 2-minute warning. We're gonna go ahead and start cleaning up. We are gonna finish the rest of this lesson tomorrow, and you guys will have your practice and cool down. Okay.
I don't know why that alarm went